So the fast AI work sounds like it could be really valuable, absolutely. Is there a particular person who's driving that who could like put up a repo and make a start? Is there someone doing that?
So there's no one specifically on the fast AI
Mm.
work, but it's kind of part of we're planning on having as part of the process as part of this
Mm.
community push. So at some point we want to coordinate effort on it. There's not one person specifically, but
Okay.
the people Kyle mentioned, we're kind of in that circle. So
Yeah, I made a GitHub team for people who are interested in helping out. I just truthfully haven't had time to continue to push things forward. So I've been trying to look for someone or a couple of people at least, to lead that and take over. And I have a couple of next steps from Jeremy, who's the guy who runs Fast AI. So happy to hand that off to whoever's interested.
Yeah, I think so we have a repo there for the larger like ML push to track all of that. The fast AI thing can be like one of our projects that we're tracking on there. And I think once we actually write that out, we can delegate some people to each project. So we'll tell you who can take that over.
right. And the other thing was the fast AI stuff requires some higher level APIs that I think might sit at a higher level than Flux. Like as far as model tuning, with pre-trained models, text, kind of analogous to Metalhead.
It's in transit.
So
Did he give you a tracking
I was
number?
talking to Anthony from MLJ, and we were kind of discussing whether it's in scope for MLJ to take over some of these higher level API layers. And I think that would be cool because number one, there's already some work in that direction from him and from that team. And number two, it spreads maintenance burden. So that's something he's interested in discussing further. So.
Yeah, and just to follow up on this, because right now in the ecosystem, there's MLJ, but there's also Julia ML, and you have this, I guess, a bit of the two organizations almost a little at odds. Not necessarily, but for somebody who's just starting in here, how do I know if I want to use MLJ base? How do I know if I want to use ML data pattern or ML data utils? So clarifying that, I think, is also part of this general can we replicate fast AI push as well.
Yeah, so I think one thing that's come up a few times is that maybe Flux needs to kind of document more parts of the ecosystem. Not necessarily that we should be responsible for documenting, every other library, but certainly that if you're working with something like TensorFlow, you would have a centralized place where you can say, how do I load data, and batch it and so on. In Flux, we kind of expect that people will use tools from outside the Flux repo itself to do that, but I think it may not be obvious which ones are the go-to tools for users who are new to the ecosystem, as you point out. So that's another thing that, we should definitely work on resolving.
Well, and one thing that's worked for DiffyQ in that aspect is really that, we've over time we've pulled in some repos, we've centralized a lot of them into the org, and we've added them to the documentation. So that way it's like, hey, this is something we've made official, right? Technically someone could go find the library and it could have its own separate documentation. But when it seems more official, it just seems to have a lot more discoverability, and it just seems to have a lot nicer flow to it. And for some of these things, it just kind of, a lot of what people are looking for too is just to know that there is a maintainer that they trust that is taking care of the library, right? That's one of the things that really stops people from taking a solution. There are legitimate solutions that are like a 10-star library out there, but a lot of people are scared to pick it up. So kind of, I think there could be a bit more recruitment in terms of, just like pulling things into a central repository and kind of making sure that there's like a natural like central documentation and like a central like authority of like that we put our stamp of approval on this. there'll always be other outside tools, and they might even be better sometimes. But I think it kind of helps in general to kind of build this outer ecosystem part.
As well, like Flux, Flux has its own implementation of, for instance, downloading ML datasets like MNIST. It has its own finite differencing for tests through Zygo. It would be nice to have a sense of, I guess, like what resources are expected to be pulled from sort of a larger community implementations. So for instance, having ML datasets be the standard way to import datasets, I think would be much nicer than, for instance, the Model Zoo, all of the examples are using Flux's built-in MNIST. I don't know if under the hood it's using ML. Maybe that changed. Things like mini batching as well. The documentation is actually like pretty painful for even just getting a one-hot coding of MNIST right the first try. It's like not the one-hot function, it's the one-hot batch function. And there's no MNIST example in the ML datasets documentation. So I think like having like people know to use the ML datasets might also have more people looking at the documentation from an ML, like from a more like neural network ML perspective. I think a lot of the ML, the Julia ML stuff is more sort of traditional machine learning, not really neural networks. At least that's the impression that I got from a while back looking at it.
Yeah, and I think,
sorry, go ahead.
Sorry, go ahead. Yeah, I think in addition to the ML data sets, we have Metalhead that has kind of some or has vision models in there. You know, if we could have like Flux models or like ML models or something that has all those architectures pre-done, because I don't think we really have that anywhere in the ecosystem consistently.
Yeah, definitely. So I just I also wanted to hear a bit from Daria to outline the plans for the Model Zookeeper, which I think is very relevant to the fast AI and model testing that we've mentioned previously. Daria, not currently audible. Okay, that's... Still nothing from Daria. Okay, that's unfortunate. Maybe try just restarting your browser or something. All right, well, we'll have to save that hopefully for slightly later in the call.
Can I ask a question about this sort of model verification process? So I have a few student projects that are sort of just doing re-implementations of things in Flux, like darts and efficient det, being two of them. And these are things that I've found other sort of attempts, and I think a lot of the times when these are student projects, what I hope won't happen, but what I'm afraid of is that, you know, the student gets to a certain point and then they move on to another thing, and then the repo just sort of sits there and is a 2-year-old implementation of something that only half works. So what's the proper way to launch a specific model development process and to make it a more sustained effort than just a sort of one-shot thing?
So just to clarify, you're asking kind of in terms of the models that we host publicly is like documentation, or is in like a private user, how they make sure their models are working over time?
Not necessarily something that is hosted by Flux, but let's say, I mean, so like YOLO.jl is a good example.
Yeah.
That seems like it's still somewhat kept up to date, but YOLO at this point is not, right? And so having like a RetinaNet implementation that uses Flux, it's not something that's officially Flux, but it would be great if somehow the Flux community could put a light onto it so that other developers maintain it, even if the original students move on, as students have a tendency to do.
Yeah, I think so. Maybe there should be kind of a slightly. Well, I certainly think that it'd be okay to have an organization, whether or not it's FluxML or something else, that hosts, high quality models, things like YOLO, and transformers.jl and possibly other things like that. So that the same as any other code, it doesn't matter whether it's a data loader or a model or whatever, it's the same kind of problem. We just want to make sure that issues get seen by someone, and there's an organization of people who can do that. So yeah, I think we'd like to kind of expand what is in the FluxML organization, or maybe a Flux models organization, I don't know, and host things like that so that there's a developer effort. There is kind of the trade-off of that against kind of adding more maintenance efforts that people are working on, all the packages that are there right now. So I think what we also have to work out is how we can maybe also expand the set of people who are willing to commit to saying, okay, I'm willing to, address issues on model packages in the FluxML organization and keep an eye on those things and make sure they carry on working. Obviously, if anyone is willing to volunteer for things like that, then we'd be more than happy to discuss. You're still in an audible area, sorry.
Mike, could you maybe go over the future of Zygote? Is that going to be rewritten with the new compiler pass stuff, or like what are the plans?
Yeah, so I mean, Zygote kind of remains one independent piece. So Zygote in the future is going to be the bit that that applies the AD transform itself. It isn't and probably won't ever be something that knows a lot about specific optimizations, for example. But what we can do is we can do the Zygote transform, and either before or after that do optimizations via kind of tracing like approaches, or via the abstract interpreter work that Kenna was doing on Base Julia. So we certainly are building those tools and making sure that they work well with Zygote. And that's kind of the approach we've taken to all these things, right? Build a bunch of separate tools that work well together. So that's kind of the rough plan. That's quite vague, but hopefully it gives an idea of where we're headed.
So there wasn't there was some discussion about rebasing it on a typed IR representation. Is that still something, or is that what you just talked about? I don't know.
Yeah, that's basically it. So I mean, Zygote's code transform can work. It just works on IR, that happens to be typed with any at the moment, but could be typed with something else. It doesn't matter. So if some other tool were to trim down the IR and inline functions and all that kind of thing before Zygote was run, then that Zygote would do the same thing. It would just generate less code at the end because the code that was given to it was slimmer in the first place. And that's kind of the approach that we're taking to that problem. Gotcha. Zygote might need extending a little bit. It might need some slightly more careful semantics in some places to do that properly, but we're not planning to like totally rewrite it from the ground up or anything like that.
Gotcha.
I guess it's worth mentioning that the type does, one way you can trim down IR significantly is if your IR has been typed, because then you can do things like delete branches that don't apply to this type.
Yeah.
But it's not the only way. So that's kind of how that, I guess, fits into it. It's that adding type information is one of the ways you can slim it down.
What about like error messages and stuff?
So which error messages?
Don't have any particularly in mind.
Oh, I have one. So if you run into a shape error, for example, on the backwards pass, right now you're going through quite a few layers of auto-generated, name-angled call stack to try to figure that out. So I think that, for example, is one of them. We had a discussion
It's the
about
second
this.
last one.
Yeah.
The trick to reading Zygote stack traces, just for reference, is to look at every second stack trace, and it's the one you're looking for.
Yeah.
It's great.
I mean, it's better than having to read through like 5 levels of TensorFlow executor stack trace on the C++ side, but obviously, I think that's something that new people would probably be intimidated by to quite an extent as well. And we did talk about this a little yesterday about how other ecosystems are trying this. For example, I think Aria knows more about this, but in Swift, because they whitelist all of their differentiable constructs, they can pinpoint and then it kind of trace back to the source areas and give better error messages in better context because of that. Because they're not differentiating, I guess, arbitrary IR like happens more so in Zygote.
Yeah, so I guess it would be interesting to understand where that kind of shape error is coming up, because I think although there are things we can talk about in solution to this, I think a big part of the solution is just kind of trying to make sure as much as possible that if your forward pass runs, then your backward pass will always also run, without shape errors, for example. So is a shape error happening because of an issue in kind of the Zygote library, or because you have a custom gradient function which is kind of a work in progress, or what kind of situation is this?
The example I can remember was probably user error, but somehow the forward pass succeeded. Something with, not sure how that worked exactly, but again, like when you look at the stack trace, you have it's not, it doesn't even say there's a mismatch. The error actually comes up in the gem implementation. So again, you need to know, for example, that, oh, well, there's expecting maybe like a rank 3 and you give it a rank 2 matrix, and then you have to kind of backtrace from there, take a look at some of the methods listings for whatever you've been working with, maybe dig down to Q arrays, etc. So it's a bit more ceremony, I guess, is what I'm trying to say, than you might expect.
It might be nice for us to have a user mode that simply filters our stack trace to remove any reference to the Zygote internals, which would, I suspect, look a lot more like what you want, so long as you've fixed line numbers on custom adjoints. Then you'd only get line numbers of things the user wrote and never anything that was inside Zygote.
Yes, we're a bit limited by Julia's message handling here, because it would be really nice to tell it, customize the stack trace in this way. And of course, this is doubly true once you start getting down. Like, you can apply this in a very general sense, right? So if you're stepping through code in a debugger in your backwards pass, you want to tell that debugger, actually ignore all this stuff which is Lego generated. Just look at the user code and the user data structures.
So I think we can actually do this one though. Filtering it is something that the test standard library does. The test standard library deletes references to itself from the stack trace. That might be inside the test macro rather than at the top level. We could add something to the language itself to add support this more generally.
Yeah, I mean, I haven't seen what test does, but certainly when I looked at this before, you find that the stack trace, you can only do this in a way which isn't very first class. So you can basically change the error printing so that when the error message prints, it prints a stack trace. But that's not the same as having the real stack trace, which has tooling support in Juno and the REPL, for example.
You can also do it by try catching at the first entry to Zygote, and then getting the stack trace, filtering it there, and returning a filtered stack trace.
Yeah.
That seems nice.
That's what that test does.
Right, yeah.
Is there any... Oh, sorry. Is there any kind of possibility that the tracing work and or some of the experimental work around typed IR and different IR representations like MLIR would help there? Because, like, say, I don't know if you'd be able to do, say, like a shape inference pass or even a D-type inference pass using one of those.
Yeah, absolutely. So I was about to mention this is kind of the second aspect of this question. People are talking about Swift and Rust error messages, which are fantastic, partly because they can do a lot of this checking ahead of time. So having more ahead of time tooling is Possibly a much bigger and more ambitious project, but probably something that may be worth looking into. I guess my personal feeling on this has generally been that shape errors are not that common, and when they are common, you can catch them about as quickly by just calling the model and getting a stack trace for the forward pass. But it'd be interesting to know from users if that assumption is not really correct, and if actually you spend a lot of time battling shape errors.
A error message that was really frustrating to my students, and we talked about this last call, so I won't beat this dead horse, but the mutating code error message is pretty frustrating when they can guarantee that the forward pass doesn't mutate anything that the gradient should depend on. And it's hard to explain to students that, like, oh yes, there's like complicated reasons why any mutation is a problem. And so it would be, I'm not really following along with the typed IR story, but if there's other inference passes that could, they could also handle something like that. That's like a perpetual gripe, especially for students who are just trying to, append losses to something to plot.
Yeah, that's a good gripe. I think slightly different in that you prefer the error message wasn't there at all, rather than that the error was better reported. But yeah, so I think that's one thing where things like typed IR might help, because as you've seen, we've gone through this on GitHub issues and so on. We just can't guarantee at this point that a function that clearly is unused to the user actually doesn't do something like mutable state and so on. So, but typed IR could help us with some of those guarantees. And so one thing I want to do with the XLA work is to actually be able to take mutating code, and because we have that global view of what's going on, we can actually turn it back into functional code that XLA supports. And so making Zygote work on those things is kind of a corollary of that we might be able to work out.
There might be something to say about just improving the callback handling that we have as of now.
Yeah.
Because it seems like one of the very common things that people face is, I just want to see my losses. That's all I really care about. So
right,
maybe
we could do that one fairly easily too, couldn't we? Because that would just
exactly.
be use zygote.ignore on the callback inside flux.train. That'd be quite good.
Not even that. I mean, we could probably just have our own callback in there, which just has a no grad on the whole of it, and that's just fine as well. I mean, we've already no graded printing and stuff, right? So like we could just reuse that in here, just writing, a login callback or something like that, which just says, do this basic callback situation.
Yeah, it's an interesting
callback
thought.
is like a secondary issue. Like the pedagogical thing that I was trying to get at is that you don't have to recompute values from the forward pass when you take the gradients.
Yeah.
Or so like basically the gradient happens in addition to a single forward pass call. And Mike and I have talked a bit about this, that like the current API doesn't really expose that very nicely, because you have to use the pullback functions to get sort of like a value and gradient call. And so maybe like another sort of temporary solution is to have sort of an additional API function, like API level function that's exposed to the user. Jax has it. It's called val and gradient. So it returns both the primal value and the pullback. Or sorry, the primal value and what would have been returned by gradient. And that way, it's still a temporary solution, because you might also want to log intermediate values, not necessarily the exact loss. And appending anything inside the gradient call will throw this mutation error. So it's not just enough to have a callback, because callbacks. Sorry, I'll let you.
Oh no, please go ahead.
I was done.
Okay. So I was thinking we could probably just refactor train to use pullback for now. Does that seem like a simple enough solution for that?
So to be honest, I rarely use the provided flux train. I almost exclusively write custom custom training loops. And this is, again, like a lot, I mentioned this at the top of the call, but a lot of my through, start out, and I'll have another thing to talk about later. But starting with Zygote and like learning the fundamentals of AD, how do you sort of stack that up into your own train loop? And so it is kind of silly to get to the situation where you just want to like, append the loss and then be like, oh, sorry, you have to refactor everything. To use like a custom train loop that's just a black box. I understand that it's like a useful thing for obviously, people who are actually trying to be productive, but from a pedagogical perspective, having custom train loops is very valuable.
Yeah, so I think I kind of tend towards Lyndon's point of view here, which is that it's very hard to build a very general train, auto train function that is general enough to cover a lot of use cases and not hamper you when you try to generalize, while also being more convenient than just writing a for loop. And we've even talked about this to the extent of just deleting flux.train entirely and instead, working out what the right components are so that people always just write a for loop and they use maybe flux.step to do a model update step. And we make those things convenient, but we don't necessarily try to do a callback API or anything like that. So yeah, I guess that's, and that would be interesting. That'd be an interesting place maybe to kind of get survey feedback as well, because it's unclear to me if this would, really turn people off, or, it seems like it's working for Jesse, but maybe some people just really need the Keras style train loop or something for some reason. So that might be an interesting thing to ask people what their expectations are there.
I was actually writing kind of just by happenstance a Keras style train loop, trying to get like a progress bar and such. And right now you do have to use pullback for that. So yeah, flex.train with the callbacks, you get some of that, but for example, you can't, like Jesse's mentioned, you can't store loss in intermediate, or it's very difficult without using pullback, but just train. There's a few things around, like you can't use coup iterator as well because of how the tuple batching interactions with unsafe free and whatnot as well without writing a custom loop. So yeah, I mean, flex.train is just kind of, you try it and then you just don't use it again.
Yeah, as I'd say that that's actually one of my motivations for using Flux, because for my own research in doing sort of odd gradient descent update methods that include either structural learning or neuromodulated learning parameters, I've had to heavily hack Keras's train methods. And I think that it's nice for beginners to have something like that, but I think that one of the advantages of Flux is that it's already flexible to do different things, but it has this facade of having like one standard training method.
Yeah. So maybe the answer is there. We just need to not pretend to be Keras there and just be Flux instead. Yeah. So maybe mentioning on the optimizers as well. So I think those are still a bit, so we're trying to work out. At the moment, they used to be worse and less composable. They've gradually become better, and we're now actually refactoring again so that they work well for XLA. The main difference there being that XLA requires everything to be functional and out of place, somewhat similar to Jax. So we really want optimizers that work well when you actually return an entirely new model and then update the model that way. And we want to kind of abstract over the difference between that and also be able to, as a special case, actually we know that the model is mutable here, so do the update in place, which is what Julia requires obviously for performance. So I think that's something that's developing quite quickly recently. But once that has developed, we'll start to like expose that and maybe expose Lyndon's flux.step method, and then possibly consider deleting the training loop. And instead just expose those, like all of those pieces which are useful for actually writing your own train loop, and hopefully around 3 lines of code or something like that. I see chat things flying by and I'm not really paying attention to them because I'm but Yes, I think it'd be quite easy to add like a value and gradient thing to Zygote, so we should do that.
Can I change a subject to something slightly related?
Please do.
Yes. So what you were just talking about with respect to XLA wanting a functional style, something that has come up, obviously, like Mike, you know about this. When we were working with Chris, the sort of explicit versus implicit model, I saw that you pulled functor.jl out of Zygote like this week, which is great. And then for other people on the call, Chris has sort of shadowed a lot of the sort of standard layers in Flux to make them sort of explicitly depend on their parameters. So Flux adopts sort of like the standard ML style for their layers, which is that they're structures that contain their parameters. And so we use the language that's implicitly dependent on their parameters. And that's like convenient because that way you don't have to carry around this structure containing all of the, or like thread your parameters through your entire model. But for a lot of scientific code, that's sort of the expected standard. As well, XLA does not like having things with mutable states. As well, from a pedagogy perspective, again, it is a little tricky to suddenly say, oh, there's no parameters that you're taking, or there's no arguments that you're taking gradients with respect to, which is like obviously a deviation from how we started when we started with just sort of like basic Zygote. Is there plans to make this sort of restructure, destructure sort of a feature possibly of the functor package? I don't know if that's the right place for it. So that like what I would love to see is Chris's fast dense. I would love to see something that made dense and fast dense the same object with some wrapper that allows it to be explicitly dependent on some parameters that sort of achieves the speed and code simplicity that Chris's fast dense works with.
So I think it's important to draw a distinction here, and because there are actually really kind of three things going on. So one is what Flux calls the implicit parameters, where you do params with Zygote, which we can ignore for the purposes of this discussion, but you know it's there. There's what Flux calls the explicit or functional approach, where you take the gradient of the model as an object, and so you get back a struct for the gradient. And then there's the fast dense thing. And really the difference between like the Chris's versions of the dense layers and so on and the Flux layers, it's not so much that one is an explicit argument and the other isn't. It's more that Flux represents the weights as a structure, as a tree of parameter arrays, whereas the diffeq side like explicitly represents the weights as a flat vector of float 64 or whatever. So effectively, it's like done the destructure restructure thing ahead of time. And the reason that diffeq has these weights, these layers, is that the optimizers and a few other things that diffeq uses don't work with structs. They can't accept a struct. They have to extract a big fat parameter. And so, of course, you could very easily convert between the two. But Chris had some problems with destructure and restructure because we haven't optimized them. And so he had these layers instead. So really, although I think we can like make destructure and restructure more well supported, and I think that's probably a good thing to do anyway. I also think like the real solution to this in some sense is to actually make the other packages work well with structures. So for example, and this is the work we're doing in optimizers.jl, compared to optim.jl, for example, we'd really like things like optim and things like optimization methods like LLPGS to work well on structs so that you can hand those optimization methods a Flux model and optimize it without having to flatten it. So really that's the answer, I think, ideally, is avoid destructure, restructure wherever possible, and to support structs, because that's what makes it to do. That's what Julia tries to do in general, right? But yeah, I mean, absolutely. I think aside from that, assuming there are still some cases where we need that flat parameter list, we should just make the structure thing fast, and then hopefully deprecate other versions of this that kind of hack around it in various ways.
Yeah. Okay. Thank you for clarifying the collision between related related things. But it's more than just the struct, right? If I wanted to provide not just a vector, but even a dictionary or a full structure containing the parameters, something that actually separates not just into a vector, that's still challenging. And it would be nice if there was I know you can provide initialization weights to a dense layer to initialize it, but it would be nice to have some sort of wrapper or macro even to convert a dense layer into something that explicitly takes its arguments always.
Explicitly takes its arguments as a dictionary or something.
Yeah, possibly as a dictionary. So to be honest, I don't have a good sense of what this should look like, and I'd like to keep sort of working on this. But having something that looks like I guess having dense be a struct that contains its parameters already serves that purpose. All right, yeah, it's tricky. I think I'll have to think more about
it'd be worth understanding better what you need from a pedagogical standpoint.
Yeah.
I think the thing that's worth really clarifying is that something the way I think of it is you start with the dictionary parameters. So that's, your LSTM weights, for example, and then you pass that into your function explicitly. Then you end up deciding, well, actually, I want to be able to abstract over and switch out LSTM for RNN, right? So you add a type tag. This is an LSTM and the parameters. This is an RNN parameters, and you have a function which applies the LSTM or whatever RNN you have. And then you say, well, actually, let's just make that a Julia type. So you have a dictionary with a Julia type, and it's callable, and then that's what Flux does, right? So in effect, it's kind of equivalent if you shift things around the right way. And so whatever you do want to do with a dictionary, a parameters, you should be able to do with dense, which is a dictionary with a type tag. But yeah, I mean, I can appreciate that logical sequence might be tricky from a pedagogical standpoint. So that's maybe something we should think about and figure out how to express.
Yeah, and from a pedagogical perspective, when you're working with Zygote and you have a function that takes in the parameters and you say, I want the gradient with respect to this parameter. Yeah. But then suddenly if you now move to Flux, you don't even provide a parameter. You do, you say the parameters of the entire chain. Maybe if there was something like explicit chain that returns a function of the parameters of the chain, and then also the initialized parameter set.
Have you seen the way that we're moving towards with XLA as well, which is that we ask for the gradient with respect to the model, not necessarily the parameters of the model, but with the model.
Okay.
Itself.
No. Yeah.
Okay, I think that's exactly what you're looking for.
I haven't seen that.
Yeah, I didn't realize you hadn't seen it. So we should discuss that. I'll ping you on Slack.
Yep. And then another thing, which is that I asked about this a while ago, and every single time I forget, which is actually inspecting the gradients. For instance, if you get the gradient object, it looks like it's grads with ... inside, and it's not clear. There's some methods that just need to be defined, like key names or something like that. It would be nice if there was a little bit more hints about how you're actually supposed to explore that object. Just because the correct way is to index into the model all the way down to the weights level, but it's hard to know that a priori. But yeah, okay, I'm very excited to see what you're doing.
I think this will address that as well, actually. So yeah, I think you're going to be happy with it, but it's going to require some code sample, so I'll mention on the AD channel.
Okay, yeah.
Just a quick question related to that. For the grads object, right now the key is all the way down to the parameters. Is it possible to have I don't know if it's syntactic sugar, but a key that's not all the way down to the parameters? Let's say you had multiple models and you're interested in the grads for the parameters of one of the models, all the parameters in that model, but not the other model. You want to collect those.
I'm not sure I fully understand the setup there. So maybe we should go over that with the code sample and Slack or something as well, if that's okay with you.
Yep.
Or maybe unless Darius posted something, do you have something you want to add to that?
Yeah, there was a peer recently which wanted to add basically some labels to all the parameters. So we could do something like indexing into the gradient software, which is like a symbol which represents the layer and the parameter that we want from that layer. Which is something that things like Torch and stuff do very frequently, which is naming every parameter. I'm not sure if that's the exact approach that we want there, but something if that's something that helps usability, maybe we could take a look at that.
Thanks.
Cool. So we're getting towards the end of time. Derry, do you want to quickly mention your model zookeeper work and how that fits in with the fast AI stuff potentially?
Yeah, sure. So I had developed basically this comment listener bot, which you can basically use to comment on a PR to run, say, particular instances of the model zoo and like test whether all of that, how that works out. So the idea is here that we just have some PR, which could be on, say, an analytic, flux, zygote, whatever, and we just create our own environment using the changes there and all the relevant packages that we might want. So currently, it's only flux, flux, zygote, and all the usual candidates. But then we can probably use this as a means of doing testing over entire models rather than just running the test suite, which we have seen can sometimes leave some test cases which are just not caught properly yet. So this way we can make sure that the actual user code that we expect people to run works and infers properly. The same thing we can apply to fast AI notebooks as well, where we're generating these notebooks as and when we need, based on any kind of changes that we see in the ecosystem. So it could be done, if we want to test any regressions in Cycle, for example, to make sure that we're doing our due diligence there. So it's just a bot which we can use to, not be CI because it takes a lot of time. It could be CI, it's just a GitHub action, but rather think of it more as something that we can call on demand when we want to test, important peers which we expect to have API changes and behavioral changes and things like that.
Yeah, so definitely once this planning repo is out and once there's some thinking about these kinds of things, we definitely get in touch with us, particularly Daria, so that we can talk about integrating all the stuff together, because I think that will dovetail together nicely. That's time, so I think we should end it there. I think that's a useful stopping point. That certainly felt very useful to me. I hope it was useful to everyone else. Thanks so much, everyone, for coming. I imagine that we'll make this a regular or semi-regular thing. So hopefully, if anyone didn't have their questions answered this call, we'll have time to have some more discussions later on. Or obviously, please do feel free to discuss these things on Slack as well. Okay, thanks everyone, and then until next time.
That was great, Mike. Thanks.
All right.